Welcome. I've decided to work an example problem for you to see if this kind of help you guys understand all the problems. This is from homework set number 2. We have our formulas. Everything in this formula is the distance traveled, x, is 1/2 at squared. That's 1/2 of the acceleration times time squared, plus v naught t. V naught is the initial velocity in the x direction. T is the time again. And we'll talk about later in 2 dimensions that v naught x is the initial velocity in x in that direction, and v naught y is the initial velocity in the y direction. Here we're only talking about one direction, so we just say naught, v naught. And the last term is x naught, which is your initial x position, which we usually, unless we say otherwise, we can take that to be 0. Then in the other equation we have the velocity at any time is your initial velocity plus the acceleration times time. V equals V naught plus AT. All of these equations are actually in English sentences, and you'll often see when I write them, I'll make sure I put in the appropriate comma or period at the end because they're English sentences. The first one is, the distance traveled is half the acceleration times time squared plus the initial velocity times time plus the initial position. And the velocity equation is your velocity is the initial velocity plus the acceleration times time. Right? And those are the two main equations we need for this example. The example is a car starts from rest and accelerates at a constant 1.243 meters per second squared. How far has the car traveled in meters in 14.301 seconds? So there are key things in the English here. The car starts from rest. What does that mean? That means the initial velocity of the car is 0. The car starts from rest. It has no initial velocity. I've already mentioned, unless otherwise stated, we can usually say the initial position is also 0. All right, so we have initial velocity is 0. We have the initial position is 0. What does that make the first equation, right? The first equation is going to be x. The position is 1/2 of the acceleration times time squared plus 0 times time, which is going to end up being 0, right? Plus 0. So at the end of the day, this is 1/2 the acceleration times time squared. All right? What's our acceleration? Well, it says it in the problem. It says it accelerates at a constant 1.243 meters per second squared. That tells us right there our acceleration, right? Our acceleration, 1.243 meters per second squared. When are we interested in what's going on, right? How far has the car traveled in meters in 14.301 seconds? So we know our time is 14.301 seconds. So here we go. We have our equation for position. Why did I know to get that one? Well, how far, right? How far has the car traveled? How far has the car traveled is all about where it is. And so now I know everything I need to know to plug into my equation, right? 1.243 meters per second squared onto 14.301 seconds squared equals, okay, I can't do this in my head, so I'm going to go over here, equals 0.5 times 1.243 times 14.301 squared. And I get 127.1 meters, 127.1 meters as the answer to this problem. So all of these problems are about identifying what you know. Well, we know v naught is 0. We know x naught is 0. We know the acceleration is 1.243 meters per second squared. We know the time that we're after is 14.301 seconds. We know we're interested in how far it goes. So we're looking for distance traveled. All right. So it's about putting together the English along with the math to come up with the solution where you put in all the parts into the correct places and calculate the amount of distance you've traveled. Hopefully this helps. Let me know, and we will move on to other examples from homeworks 3 and 4. Have a great day.